Hi everyone. So this is going to be a development update here on Sprint Kart Racing. I think it's the second one that I've done here in recent times. I had to solve a technical problem on the track, and I just kind of wanted to show the setup that I came up with to solve it. I want to make a disclaimer right off the bat that the track here that we're looking at and the karts that are going to be on it and everything is a work in progress, and this art is not final. The light map was just a hasty light map that's not even done properly. The light map UVs are not even done properly. The lighting's not really baked properly, but it serves as a test bed for performance on features I will use down the road. Basically, I'm just testing these texture resolutions. I'm testing running it with light maps applied, different materials, with this staggered transparency I have for the tree lines, and all kind of stuff like that. So I just want to make that disclaimer that it's not going to look super pretty right away. Also, by the way, if it looks kind of different, that's because I have this shader that's actually using the light map that's baked, and it's using vertex colors, so it allows me to, it looks strange from up here, but when you're actually down here at ground level, these variations in the color or whatever of the grass and the ground actually looks really natural for the breakup, and it helps break up a tiling texture. I haven't quite done the all the sand areas, and these curbs are not properly embedded yet, and they don't have end caps done, and they're not fading into the grass good, and the light map's baked like a funky hovering shadow. But there's going to be these decals all around on this material here that will allow for these dirt blends and things like that. They'll look really cool and have sand and dirt areas. So the problem that I needed to solve kind of goes right into that, which was I needed the player's kart object to be intelligent over whether it was driving on asphalt or tarmac, or whether it was driving on grass or a curb, right? So I established three types of materials that I wanted the kart to be aware that it would be on. I needed it to know, am I on the asphalt? Am I on this curb? And I'm on this grass? Because basically, the sound effects when you're riding over those and sliding is going to be different on asphalt, grass, and curbs. And the particle effects that are kicked up when the wheels are sliding over it are going to be different. So I looked at several different versions of ways of doing this, right? Like researching this, and some of them were reading the texture underneath of the car with a raycast, and that's just too much for mobile devices. Some of them were breaking out your collision into, you know, the road's on its own separate collision piece and the grass is on its own separate collision piece, but I didn't want to afford to put that high detailed collision in there just for surface detection, so that was too expensive. And my collision's really optimized, so this level's like 4,000 triangles, and then this collision mesh is actually like 800 triangles, 800 or so super optimized. You might be asking why all these divisions if it's just a mostly flat plane, and that came from a lot of experience working on these Need for Speed games in studio, and we always had these bugs with EA's QA. We were doing the Nintendo ports. With EA Black Box, they would always send these QA reports to us that their testers were falling out of the world, or being able to push themselves out of the world, or when they were having a high velocity collision with AI or other players, being pushed out of the world. And after lots of trial and error, we discovered it was having really large triangles in the collision, and basically it didn't have a fine enough resolution of vertices, basically points, for the collision to have nice accurate detection. So we would have to add divisions to the collision geometry to kind of get the collision to be somewhat okay. So that's why I add all these extra divisions, just in case. It's still really optimized. But it still didn't allow me to use the collision to check whether I'm on this, because I just didn't have the detail in the collision. So my third thought that I thought was genius was, well, let's create like, let me create an empty. I thought, let's use the 2D stuff and use component physics 2D and like this polygon collider here, because you can go and flatten this out and you can go and set points on it, and you can basically move these arbitrary points around. But then when I did a few tests, like if it's in the perfect spot to pass, your collision of the cart passes through it, yeah, it'll hit it and trigger it. But it has no depth up and down in Y. I know it's showing the Z-axis. That's locally to the object. Yeah, not world. Up and down in Y. If the cart like hit a bump and was, let's just say it was flying higher than this for some reason, or went below this, it wouldn't hit this, right? And so I thought, well, it needs some depth. It needs to be like a volume. And then I didn't want to go in and create more art, collision geometry to make volumes in 3ds Max. I wanted to just be able to do this in the Unity editor. So I started to Google, and Google actually led me to, I keep notes here of this. Google led me to this guy's blog here, credited to this guy. His name's actually Alex. Let's go over here. You can remember this URL. The blog's called AVA. This was a long time ago, but he updated the project to Unity 5.2 in the Bitbucket, right? And he describes these issues of needing simplistic yet detailed trigger areas or volumes. Like if you have a water sound effect when you're in the water, you need it to be in the shape of a river. And I also considered this placing multiple boxes. So we would have really hundreds of boxes around this track primitive collision, and that just wasn't an option. So he went in here and proposed a solution, came up with some nice boilerplate code here for if you're in the trigger, if you've exited it. He shows you a little image of what it looks like when you go into this volume area. And then last but not least, at the bottom is this Bitbucket here. And this is where you can go in here and just grab everything he gives you, the scene and all of that. And it is free, right? And that's him right there, Alex Abil. I don't know how to pronounce his name, but that's the guy we want to give credit to for delivering this. And if he's cool with it, I'm going to put him in the game's credits as helping with this. So I brought his system in, and we got a scene here called main scene, and he demonstrates the player as this little sphere. He has some scripts on it that are just moving it. It has a sphere collider on it, and then his trigger area script right here, which is this trigger volume, and you can display the handles. And so we can grab handles, and you can see how this is handy now. And we can just draw this in the Unity editor. You can also convert back to a collider and convert back to a trigger. Very handy if you just want to actually use it as collision. You can add points to increase your resolution. So if I know this is the point and I want to add one nearby here, I see that it needs to go here. And did I not add it? Maybe not. Yeah, there we go. So there, I added it, and now we can go around and just create a finer resolution. I think I have some overlapping shapes here. Yeah, I kind of jacked it up a little, didn't I? Be careful with that. Okay, so I'll show you how I used it in my scene real quick, and we'll demo it working. Okay, so I have these two things, grass triggers, and I needed 3 types of materials, right? Grass, asphalt, or curb. I'm not done drawing them. That's why this blue one's not finished. You can look at mine, and you can see the crazy amount of handles that I drew, and I'm grabbing some of them. But I went around and I drew them. But I can edit this very rapidly in the Unity editor, and that's very handy, right? So I have two of them. I'm working on them. I added a script to these called ground zones trigger, okay? And I add it directly onto the trigger itself. We're going to hide these. No, we don't have to hide them. I can go in here and just basically turn down the on this hidden shader it's using. Just turn down the okay. And so I put this script on it that I wrote called ground zones trigger, and it lets you just go in and say this trigger right here is a grass area, or it could be asphalt, it could be curb, and that will send message to the player cart and tell it what type of surface that cart is physically over by what the volume it is within. Okay, so ground zones trigger here is just this enumeration type right here. It allows me to have this little pull down in here and set the type because I expose it here at this variable. And then I access the surface type zone script. This is a script that's on the player cart. This is the script that's like the brain on the cart of, I'm on top of this type of surface. I'm on grass, right? He's excited about being on grass or asphalt, right? And then I made a note for myself, hey, this script is the one that's put on the trigger colliders. And then in start, I find the player. After a 1 second delay, I make sure the player is instantiated into the world, and then we grab the script that's on the cart, the script that's called surface type zones. And I called that script in the variable script, which is bad programming practice, but I work alone. I have no collaborators on this, and I'm an army of one, a studio of one, so I called it script because I know what that means in here. And so we just find the player in start. We're not trying to get a new reference to that every frame. We just do it when the scene starts, so we're not taking that overhead on that. And then we just have the on trigger enter, on exit, and on stay. So they do what they mean. So it says when another collider has entered this trigger, and that's what this collider other is. This is the cart. This is the player. Any other collider that's entered. Okay, any collider. It could be the AI, a ball. And then we say, all right, collider's entered. Let's do this. And the next check is, let's check and see what the tag is. If it is player, so then it's going to disregard everything else. The tag of ball, the tag of AI. It's just going to do the next set of things when it's a player. So then we go into this set of instructions, which is where we say, is that ground type grass? Is it asphalt? Is it curb, right? These three types. And that's where we set this right here. If it's grass, then on that script that's on the player cart, tell it that grass is true. We're in a grass area. Tell it that we're not in an asphalt area or curb area. And so on and so forth. It does this down. If we're on asphalt, hey, we are not in a grass area anymore. We are on asphalt. We're not in curb. Right? And it's sending this right here, this information to that script on the player in real time. And then when we exit, we say if it's, a collider other than myself, if that tag is player, so if it's the player, not the AI or whatever, and I can do checks for the AI to get them to do this later on, then it's not a grass area, it's not a curb, it's asphalt if we exit the trigger. Okay? And that basically works because if you're not in one of these triggers, you're on asphalt. If you're not on grass or a curb, you're always by default on asphalt. So I don't need to make a trigger for asphalt. Basically just making triggers for the grass and then eventually for these curbs, and that's it. If you're not in one of those, then you're on asphalt, right? That's a lucky happenstance. So what we're going to do here is I'll just show you it working, and we'll look at those Boolean variables on the cart being changed in real time. Let's just check the script out on the cart. Okay, so there it is, and that's the surface type zone script, and on it, on the cart, I'm going to drag it into the scene real quick. There is an audio source inside of it dedicated just to playing the audio for squealing tires on asphalt and grinding tires on, or like rough, dirty sounding tires on grass. And then of course that rumble sound you get over the curbs, right? So we don't have to plug an audio clip in that because this script's going to actually assign these clips into that. And so here are the Booleans. This is when the cart's been told by the trigger, you're in grass. No, wait, you're in asphalt. No, wait, you're on a curb. And depending on what you're on, this is the skid sound for being on the grass. This is the skid sound for being on the asphalt. And you can just go in here and basically pick. I could make it sound like wind or farting sounds or whatever, anything I want. Right? And these are the particles kicked up over these certain areas, right? And then this is just the volume of that skid. Sometimes the skid volume was too light to hear. Sometimes it was louder than the engine's one, but this adjustment allowed me to kind of just tweak it in real time, real handy. What else? So these are the particle effects that are spawn up. When you're going to see them, these are not particle effects I worked on or did any kind of artistic pass on or anything. These are just literally default particles I grabbed out of the standard assets or whatever, and they look kind of cruddy. And also the method that I'm using in this code here to turn these particles on and off is just a very standard game object set active, set false. It's literally doing this. Turning them on, turning them off. They simulate, they don't. And so the effect you're going to see from that is that they just disappear when they're turned off, and then they magically appear when they're turned on. And that's not the way you want it to look. We're going to just look at it. I'm going to run it. So let me just hit play. Turn it down just a bit. Oh, we need the game UI. I've been disabling that for just working here. And then we'll look at our cart. We don't really need to see the play window too much, but you can check these variables out here on the cart. And also for optimization, none of this check is happening, and the cart isn't aware of any surface until it's in a skidding state. So we're actually checking for sliding. So here we go. We're sliding over dirt. We're sliding over asphalt. And it's saying which surface we're over when we go into that volume. If I feel like the detection is off, I can change where those volumes are and basically modify them. And it seems to be working really well. If we follow the cart around, you'll see see how the particles just in the transitions, they just disappear and turn off. And that's because I'm literally doing this checkbox set active. Let's see, my collision's not accurate there. I told you this is a work in progress. And there's no collision on the starting game. But it's working, and it's solved my problem so far, and I'm really excited to make some triggers for those curbs and get a really cool sound when the cart rolls over those curbs as well. So hopefully this was informative and gave you guys maybe a tip that you can use in your own games. I've tested this on some pretty old spec Android devices. We're talking Galaxy S2 era, and we have Galaxy S7 phones now, and like these Asus Zen phones that are really cheap. And this is running between 50 and 60 FPS on these devices. So I can imagine on the newer devices it will be just dying to go over 60 frames a second if it's even possible on the device. So it's very performance friendly. And until the next update, I will read you guys' comments and provide any information or answer any questions that you have. Thank you for watching.